Hello guys, in this video I'm gonna show another example of Bode plots, but now it's for a high pass filter. Okay, so last time we show a function h of omega that represent if we draw the magnitude low pass filter. Okay, this time it's high pass filter, and again you don't need to watch other videos that I produced before. You can watch that, and I'm gonna also go back and forth and review what we learned and how to draw Bode plots again. Okay, but of course faster. It's not like before. Okay, so again, when we first studied, how to draw or plot a Bode plot for an h of omega, we studied that using some simpler forms, standard forms, like a constant, h of omega equal a constant, or a 0 g omega, or g omega to the power of minus n, or 1 over g omega to the power of n, or a simple 0 like that, or a simple ball like that. Okay? So the first thing to do is to convert the h of omega given into some standard form or a multiplication of standard like forms. Okay, so the first thing to do is to convert h of omega into a standard form. Okay, let's go back to our formal color here. Okay, one of these or a multiplication of these. Okay, so in that case here, okay, looks like this 10 will be like k, right? But we are not sure yet. Okay, this guy is similar to that guy, but this guy is 1 plus g omega over omega c or over something to the power of n, but n here is 1, so that's okay. But the problem is it's not 1, it's 1000 plus g omega. So, and this guy here looks like this one. Okay, it is in the denominator. Okay, it has like a power. Here is n, here is 1, that's fine. Or n equal to 1. But again, it's 1 plus something. Here it's 10 to the power of 4, 10,000 plus something. So how to do that? So we're gonna take common factors. Again, h of omega equal to 10. Then we're gonna take, to make this one, we have to take 1000 as a common factor. So 1000, 1 plus j omega divided by 1000. Divided by, to make 10 to the power of 4, 1, like this, we have to take it as a common factor. So 10,000 or 10 to the power of 4, that's fine. 1 plus j omega divided by 10,000. Okay. Now, this guy will go with those guys. Because 10 multiplied by 1000 is 10,000, so they're going to cancel each other. And we end up with two terms multiplied by each other or divided by each other. Okay. 1 plus j omega over 1000 multiplied by 1 over 1 plus j omega over 10,000. Oh, that guy is similar to simple 0. N equal to 1. The exponent is 1 here. This exponent is 1 in our case. And omega c is equal to 1000. The cutoff frequency is 1000. And this guy is similar to a simple bool. Again, n equal to 1 and omega c is equal to 10,000. And we know how to draw this. We know also how to draw this. Okay? It's very simple lines, added or linear lines. And for that reason, when you draw each one individually, you can easily sum up together both curves, or not curves, not straight lines together in the Bode plot. That's the brilliance, or this genius idea or proposal by Bode. Okay, so let's draw that. Okay, first we draw the magnitude of h of omega. Magnitude of h of omega will be the magnitude of when you have again h equal to some complex number multiplied by another complex number, the magnitude of h equal to, of course, the magnitude of the multiplication, but you can divide it. So it will be the magnitude of Z1 multiplied by the magnitude of Z2. So it's equal to the magnitude of 1 plus j omega over 1000 multiplied by the magnitude of 1 over 1 plus j1 omega over 10,000. Okay, and again, we don't draw h of omega. We draw 20 log h of omega. So 20 log h of omega is the magnitude of h of omega equal to 20. And when you have log of something, two terms multiplied, you can have log of the first plus log of the second. So for example here, log magnitude of h equal to log magnitude of z1 multiplied by log magnitude z plus, I'm sorry, multiply, plus, not multiply. So multiplication will turn it into plus. So 10 log magnitude of 1 plus j omega over 1000 minus or plus, let's make it very detailed, the plus 20 log 1 over 1 plus magnitude of 1 plus j omega over 10,000. Okay, I'm gonna simplify it more. So 20 log, and the magnitude of 1 plus j omega over 1000 is the square root 1 square, which is 1, of course, and omega squared, or like make it like in that case, omega divided by 1000, and all of that is squared, plus 20 log. Yeah, here you can bring that to the numerator who's minus 1. Okay, so with minus 1, and what is the magnitude of that? Again, square root of 1 plus omega divided by 10,000, and all of that is square. So simplify final simplification, 20 log square root 1 plus omega over 10,000, I'm sorry. Minus, not minus, not because log x to the power of, for example, minus 1 equal to minus log x. Okay. So we're gonna drop the minus here, 20 log, and you have the square root 1 plus omega over 10,000. Okay, okay, that's 20 log magnitude of h of omega. Now how to draw that? Divide and conquer. Okay, so we're gonna look at each term by itself. This term, simple 0, and this term, which was a simple. Okay, by itself. This one here, which we can call number 1, and this one's a minus 20 something, we can call it number 2. So for number 1, the 20 log square root 1 plus omega over 1000 square. When we studied that last time, or the one before, we divided in two halves. Okay, we have two cases. When omega over 1000, 1000 is omega c, is a cutoff frequency, is much less than 1. In that case, we can approximate 20 log all of that into 20 log square root of 1. We can neglect basically the omega over 1000 to the 1. Okay, so 20 log square root of 1 is 1, and log 1 is 0, so that's equal to 0. So for all values of omega that is much less than 1000, or for omega over 1000 is much less than 1, the h of omega log will be 0. Case number 2 is the opposite. Omega over 1000 is much higher than 1. In that case, we can approximate 20 log, same guy, into 20 log. Now we're gonna neglect the 1, okay? So that will be square root of omega over 1000 square, which is 20 log omega over 1000. Okay, omega c is 1000. So we're gonna put some points and and see what's going on. For omega equal to 1000, that will be 20 log 1. Log 1 is 0, so that's 0. Omega equal to 10 multiplied by 1000. 10 multiplied by 1000, that's 20 log 10, because 1000, so 10 multiplied by 1000 over 1000, this will go with this, and you're going to end up with 10. So log 10 is 1, so 20 multiplied by 1 is 20. Another example, omega equal 100 multiplied by 1000, which is 100,000, of course. That will be log 20 log 100. 1000 will go with 1000 in the numerator, and you left with 100. Log 100 is 2. 2 multiplied by 20 is 40. Good. Number 2. Minus 20 log square root of 1 plus omega over 10,000 square. Again, this is very similar to this one, but we have just minus in the beginning. So case 1, when omega over 10,000 much less than 1, so the 20 log square root of 1 plus omega over 10,000 square will be approximated as 20 log. We're gonna remove the omega over 1000 square. So it's gonna be square root of 1. Square root of 1 of 1 is 1, which is 0. So for all omegas, that is omega over 10,000 is much less than 1, or when basically this says for omega much less than 10,000, that's why omega over 10,000 is much less than 1. These values will be 0. Number 2, case number 2, when omega is much higher 10,000 or omega over 10,000 much higher than 1, in that case the 20 log, this one here, will be approximated as 20 log. We're gonna remove the 1. So omega 10,000 square, that's 20 log omega over 10,000. Okay. Then we put some examples and see how it goes. Omega equal to 10,000, exactly equal to the denominator. In that case, 20, it will be 20 log 1. 20 log 1 is 0, so 20 multiplied by 0 is 0. Omega equal to 10 multiplied by 10,000, like 100,000. That will be 20 log 1, 10. It is 1, so that's 20. Omega equal to 100 multiplied by 10,000. That will give you 20 log 100, which is 2. 2 multiplied by 20 is 40. And you can continue to be 60, 80, and so on. Okay. Oh, I'm sorry. There is minus. Oh, that's the common mistake that I usually do. Minus 0 is 0, of course, 0. Minus 20, minus 40. So if you continue, it will be minus 60, minus 80, and so on. It's exactly opposite to this one. Although there is like a shift in this. Because here we start by 1,000, here we start by 10,000. Okay. Now let's draw that. Okay. Let's draw that. So, I'm gonna go back and draw the axes. We have the y-axis. The y-axis is linear scale. Okay, like that. That's 0 dB, 0 decibels. Log something, usually the unit of that thing is decibels. 20 decibels, 40 decibels, 60 decibels. Minus 20 dB, minus 40 dB decibels, minus 60 dB. And we have like the horizontal scale or axis will be logarithmic scale. Here, as you see, we add each time 20. We add 20. But in the logarithmic scale, we multiplied by 10. If we start by 1, I don't start by 0, because if you multiply by 0, it will be 0 all the time, right? So you start by something like tens. 1.1, 10.01, something like that. Or if you are, for example, WC is equal to 2, You start by 0.2, then 2, then 20, 200, and so on, based on omega C. Here is omega C is either 10,000 or 1,000. So it's easy to use the ones, multiples of ones. Okay. So 1, 10, 100, 1,000, 10,000, 10 to the power of 5, 10 to the power of 6. This is omega. Okay. Now let's draw one. So we have two curves here. So let's draw number 1. Let's draw it by red. So for number 1, we have two cases. When omega is much less than 1,000, or omega over 1,000 is much less than 1, basically, we have 0. So where is 1,000? Here is 1,000. For all these values, we have 0 until we reach 1,000. At 1,000, there is 0. You must have 0 at 1,000. Then at 10,000, we have 20. At 10,000, we have 20. At 100,000, we have 40. 100,000, which is 10 to the power of 5, we have 40. And so on, by the way. If you 1 million, it will be 60, and so on. Then you connect them together, and this is number 1. Now let's do number 2 with another color. Let's do with yellow, for example. Okay, for number 2, for omega much less than 10,000, it is 0. For omega divided by 10,000, much less than. So for all these values here, we have 0. So the red and the yellow will be both zeros until 1,000. Then you're gonna divert at 1,000. The red will go up linearly, and the yellow will continue until 10,000 is also equal to 0. Then for case 2 here, when omega over 10,000 much larger than 1, okay, you have 0 at 10,000. That's what we have. You have minus 20 at 10 to the power of 5. It is minus 20. Oh, sorry. At 100K. Then you have at 1 million, you have minus 40. And you connect these points together. And if you continue, you're going to have, for example, at 10 to the power of 7, you're going to have minus 60, and so on. That's number 2. Now, how to add them together? You can add them with another color. Green, for example. So again, you have like the what I call the breaking points, the points at which there is some change, okay, including the 0. Although there is no not the 0, so it's the first one, which is 1. Okay, so we have this point, we have also that point, and we have that point. Sorry, I will not mark them in that way. Just to put like a dash or something, check mark. Okay, and we can take 1 or 2 points, afterwards. There is no change at this point and this point, but we're gonna take it, and also this to see the trend. Okay, so from 1 to 10 to 1,000, 0 plus all the red are 0. The red is equal to 0, and the yellow also equal to 0. So 0 plus 0 is 0. So we're gonna have again 0 until 1,000. At 1,000, again, the yellow is 0, the red is 0. So the addition of both is also, that's a point. Let's go to 10,000, 10 to the power of 4. The yellow is 0, but the red is 20. 20 here. So 20 plus 0, 20. So that's a point. At 10 to the power of 5, the yellow is minus 20. The red is 40. That's total 40. At 10 to the power of 6, the yellow is minus 40. The red is 60. So the total is 20 again. And you're gonna continue with 20s. So let's now connect them to each other. So I'm gonna go up, continue all the green dots together. Oh, so that's the opposite of the low pass filter. If you go back here to check the low pass filter that we talked like last time, look at the low pass filter. It starts by 20 dB, then goes down to 0. This guy here starts by 0 and then goes up to 20 dB at some certain frequency. Okay? Let's review what that means. Again, remember that H of omega can be, for example, V output over V input. And all of these guys are function of omega, function of the frequency, change by the frequency. Okay? So, and from that equation, V output is equal to H of omega multiplied by V input. Okay? So, if the input frequency, omega I, which is 2 by F, the frequency is F, omega is angular frequency, it has a relation with it, is less than 1000, that means the output will be 0. I mean, if you have a signal that goes into that circuit, okay, let's assume this is the black box that is represented by H of omega. And here is your input, and here is your measure the output. So if the input frequency is less than 1000 or 2 by 1000, this is the angular frequency, okay, that means the output will be 0. You will not measure anything. But although you have input, nothing goes out. And if the output angular frequency is higher than 10,000, there will be output. It might be like exactly equal to the input or higher or lower. In that case, it might be higher, I'm not sure. But there will be output, okay? And I believe it will be equal to the input. And in between here, it will be fraction of the input, okay? So there is output, but it will be fraction of the input. But the maximum output will be the maximum output, the maximum here, when omega I is greater than or equal to 10,000. So low frequencies doesn't pass. So low frequency doesn't pass. High frequency passes through the circuit. Okay. So high is passing, lows doesn't pass. So that's high pass filter. So that's a high pass whatever filter. Okay. That's completely the opposite of the low pass filter that we talked last time. Last time we pass the low, if we go back, we pass low frequencies, we reject high frequencies. Look at the output is 0 at high frequencies. Here, we don't pass, we reject low frequencies, but we pass high frequencies. Okay, guys, that's basically two good examples to show you the meaning of filtering in circuits, okay? In an abstract way. There is in the book, like our book, there is examples for band pass filter, like a filter like that, or 20 log H of omega magnitude is like that. And in that case, we pass frequencies between omega 1 and omega 2, or omega C1 and omega C2. We reject the low, we reject the high, we only take band. This is called band pass filter. There is another example, much more interesting, in which you take the low, you reject a band in between, and you take the high. So you only take the middle here, or like this band. Here you take the low, you take the high, you reject the intermediate ones. That's called band reject filter. Okay? And these are very good examples. You have them in the book, by the way. So as an exercise, go to the book, solve this exam, try to draw the body plot yourself. Oh, I think this is the example in the book. Please do it. Okay, guys, thank you very much for watching and see you in another video. Bye bye.